This code is for doing stock prediction using a machine learning model called XGBoost. It installs the necessary libraries such as scikit-learn, XGBoost, Finance, and Finta. These libraries provide the tools and functions needed to work with stock data and build the predictive model. By using XGBoost, we can train a model to predict future stock prices based on historical stock data. The code downloads and installs these libraries to ensure all the required dependencies are available. After running this code, we can proceed with loading data, pre-processing it, and training the prediction model. This code begins by importing necessary libraries, pandas, NumPy, matplotlib, Finta, and Finance. These libraries are used for data manipulation, mathematical computations, plotting graphs, and accessing stock market data. The code then sets the plotting style to Seaborn and ensures that the graphs are displayed inline. The purpose of this code is to predict stock prices using the XGBoost algorithm, which is a machine learning technique. The XGBoost algorithm is not explicitly present in this code, but it may be used in subsequent parts that are not shown here. To perform the stock prediction, the code uses technical analysis indicators provided by the Finta library. These indicators are applied to historical stock market data obtained from the Yahoo Finance API using the Finance library. Overall, this code sets up the necessary environment and imports the required libraries for stock prediction using XGBoost. This code is used to download historical stock data for Microsoft, MSFT, using the Yahoo Finance API. The stock data is downloaded for the time duration from January 1, 2017, to December 20, 2021. The downloaded data is stored in a DataFrame, which can be further processed for stock prediction using the XGBoost algorithm. This code is used to plot the historical close price of a stock. It imports the necessary libraries and sets the plot size. It then sets the title of the plot and plots the close price data from a data frame. The x-axis represents the dates and the y-axis represents the close price in US dollars. Finally, it displays the plot. The code is used to calculate and display a statistical summary of a dataset. Specifically, it applies the describe function to the data frame named df. This function generates various statistical measures such as count, mean, standard deviation, minimum and maximum values, quartiles, and more for each column in the data frame. The result will be a summary table that provides an overview of the dataset's distribution and central tendencies. This code calculates various technical indicators for stock prediction using the XGBoost algorithm. It adds columns to the data frame for the simple moving average, SMA, over a period of 200, the relative strength index, RSI, the average true range, ATR, the Bollinger Band's width, BB width, and the Williams percent R, Williams, indicator. After calculating these indicators, it selects a subset of the data frame by excluding the first 200 rows, effectively removing the initial rows that do not have enough data for the SMA 200 calculation. This code is a part of a stock prediction using XGBoost algorithm. The line df.tail10 is used to retrieve the last 10 rows of a data frame called df. It helps to display the most recent data in the dataset, allowing us to observe the latest trends and patterns in the stock market. The code is primarily used for data analysis and visualization before applying the XGBoost algorithm for making accurate stock predictions. This code is a part of a stock prediction model using the XGBoost algorithm. It adds a new column called target to a data frame called df, which contains the closing prices of a stock. The target column is created by shifting the close column one row up. Then, it removes any rows with missing values using the dropna function. Finally, it displays the first few rows of the modified data frame. This code defines a function called train_test_split. It takes two inputs, data which represents the dataset and perc which represents the percentage of data to be split for testing. The function first converts the input dataset into an array using the values method. Then, it calculates the number of rows to be used for training by multiplying the length of the data array with 1, perc, and converting the result to an integer. Finally, the function returns two arrays. The first array contains the rows of data up to the calculated training index, and the second array contains the remaining rows of data for testing purposes. In this code, the dataset is being split into training and testing sets using a function called train_test_split. The train_test_split function takes in the dataset df and splits it into two parts, with 80% of the data being used for training and 20% being used for testing. The training set is stored in a variable called train and the testing set is stored in a variable called test. This code is written for stock prediction using XGBoost. The first line of code prints the length of the DataFrame df. The second line of code prints the length of the variable train. The third line of code prints the length of the variable test. The last line of code accesses the first row of the train variable and excludes the last column from the row. This code is used for training a stock prediction model using the XGBoost algorithm. The train variable contains a dataset that is being split into two parts. The first part, assigned to the variable x, contains all the features, or input variables, of the dataset except for the last column. This represents the information used to predict the stock prices. The second part, assigned to the variable y, contains only the values of the last column of the dataset. This represents the target variable, or the actual stock prices that we are trying to predict. Overall, this code separates the features and target variable from the dataset in order to train a model for stock price prediction. This code is using the XGBoost library to create a model for stock prediction. It is importing the necessary libraries and defining a dictionary called params which contains different parameters for this XGBoost model. The parameters include max_depth which determines the maximum depth of each tree in the model, learning_rate which controls the step size in each boosting iteration, n_estimators which specifies the number of trees in the model, and col_sample_bytree which determines the fraction of columns to be randomly samples for each tree. Then, an XGBoost object is created with a specified seed value. The grid search function is then used to perform a grid search over a range of parameter values. It takes the XGBoost object as the estimator, the params dictionary as the parameter grid, neg_mean_squared_error as the scoring function, and verbose equals 1 for detailed output. The fit method is called on the grid search object with the training data x and y, to train the model using the best combination of parameters found during the grid search. Finally, the code prints the best parameters found by the grid search and the lowest root mean squared error, RMSE, score, which is the negative of the best mean squared error, MSE, score found during the grid search. This code is using the XGBoost library to perform stock prediction. It creates an instance of the XGBoost class with certain parameters. These parameters define the objective function, the number of estimators, the fraction of features to consider when building each tree, the learning rate, the maximum depth of each tree, and the amount of regularization to apply. It then uses this model to fit the input data x and labels y, training the model to predict stock prices. This code snippet is used to access the first row of the test dataset. The test dataset is likely a table of data related to stock prices or something similar. By using the index 0 in the code, it selects only the first row of the dataset. The purpose of this code could be to retrieve or manipulate the specific information associated with the first row. This code is a part of a stock prediction system that uses the XGBoost machine learning algorithm. First, it takes the first row of the test data and removes the last element using the :-1 slicing syntax. Then, it reshapes the resulting array into a 2D array with one row. This array represents the features of the stock data for a particular instance. Next, it uses the trained model to predict the stocks valued based on the given features. The predict function takes the reshaped array as input and returns the predicted value. Finally, the pred variable stores the predicted value. This code is used to predict stock prices using the XGBoost library. The code takes in a training dataset and a validation dataset as input. First, the training dataset is converted into a NumPy array. Then, the features and target variable are separated from the training dataset. Next, a model is created using the XGBregressor class from the XGBoost library. The parameters for the model are set, such as the objective function, number of estimators, learning rate, and maximum depth. The model is then trained on the training dataset by fitting it to the features and target variable. After that, the validation dataset is converted into a NumPy array and reshaped to have the same number of columns as the training dataset. Finally, the model predicts the stock price for the validation dataset and returns the prediction. This code is making use of the XGBoost model to predict stock prices. It calls the function XGB_predict, passing in the training data and the features of the first record in the test dataset except for the last column. The goal is to use the trained model to predict the stock price for this particular record. This code defines a function called MAPE which calculates the mean absolute percentage error, MAPE, for a set of actual and predicted values. It takes the actual values and predicted values as input, converts them into NumPy arrays, calculates the percentage difference between each pair of values, takes the absolute value of the difference, and then calculates the mean of these absolute differences. Finally, it multiplies this mean by 100 and returns the result as the MAPE. This code is for stock prediction using the XGBoost algorithm. It imports the necessary library, sklearn.metrics, for calculating mean squared error. The code defines a function called validate that takes two arguments, data and perk. Inside the function, the data is split into a training set and a test set using the train_test_split function. Then, a variable called history is initialized as a list containing the elements from the training set. A loop is then executed for each element in the test set. For each iteration, the input features, x_test, and the corresponding target value, y_test, are extracted from the test set. The function XGB_predict is then called to predict the target value using the history data. The predicted value is appended to a list called predictions. After the loop, the mean squared error is calculated using the actual target values from the test set and the predicted values. The function MAPE is used to calculate the mean absolute percentage error, MAPE, between the actual and predicted values. The final output of the function includes the error, MAPE, the actual target values from the test set, and the predicted values. This code calculates the root mean square error, RMS, mean absolute percentage error, MAPE, actual values, y, and predicted values, pred, using a function called validate on a given DataFrame df, with a train-test split ratio of 0.2. This code prints the values of RMSE and MAPE, which are likely calculated metrics used to evaluate the accuracy of a stock prediction model. It then prints the values of y and pred, which are probably the actual and predicted stock prices respectively. This code takes the predicted values from a stock prediction model and converts them into a NumPy array. Then, it combines these predicted values with the original test dataset using the np.c_ function. This allows us to see the predicted values alongside the corresponding features in the test dataset. This code creates a pandas data frame called df_tp. The data frame has columns named open, high, low, close, adjective close, volume, SMA 200, RSI, ATR, BB width, Williams, target, and pred. The values for these columns are taken from the test_pred array. This code is responsible for plotting the next-day close price of Microsoft's stock and the predicted price using XGBoost. The plot is displayed with the help of the matplotlib library. The x-axis represents the dates, while the y-axis represents the price of the stock in USD. The cyan line represents the actual closing price for the next day, whereas the green line represents the predicted price. The plot also includes a legend and labels for the x-axis and y-axis to provide a better understanding of the data. This code starts by importing the necessary libraries for the task of stock prediction using XGBoost. The next line loads the stock price data into a pandas data frame called df_tp. The code then performs some transformations and feature engineering on the data to prepare it for training the XGBoost model. This includes creating lag variables, scaling the data, and splitting it into the training and testing sets. Finally, the code trains the XGBoost model using the training data and evaluates its performance on the testing data.